Hi, my name is Youngbo Aram Shim, and in this video, I'd like to shortly present our work FSPAD, Video Game Interactions Using Force Feedback Gamepad. This work was done with my great collaborators Keunwoo, Sangyoon, Jeongmin, Taeyun, and advised by Geehyuk, all in UIST. Haptic feedback was first introduced to the video game world back in the 90s. Since then, vibration was the major modality to convey sense of touch in video games. However, talking about haptic feedback, there is a rather unexplored sensation, force feedback. There are some commercial force feedback gaming gears as you see here. However, these devices require a large space and are limited to specific game genres such as racing or flight simulations. In this study, therefore, we tried to implement a force feedback gaming device in most familiar video game form factor, the Gamepad. Also, we tried to develop novel game interactions using this device. And here is a short teaser of the FSPAD, our gamepad with a force feedback thumbstick inside. It could move by itself or render various haptic structures. With no force output, it is stationary in its place, but when force is rendered, it returns to the center points, simulating a normal spring thumbstick for this case. This is the working mechanism of the FSPAD, two-axis gimbal structure with coreless motors and position sensors. The FSPAD is an open-loop impedance control device. It outputs the desired force based on the position of the stick. The majority of the haptic rendering was done on an intermediate processor. For detailed construction and specification, please see our paper or project page. Now, I would like to show what novel game interactions could be enabled by the FSPAD. We have 5 interaction themes for describing the scenarios as shown here. These are not completely exclusive to each other. I'll briefly go through representative scenarios for each theme. The FSPAD could serve as various inputs and could be reconfigured at real time. Some of the examples are given. Below icons show the force rendering of the FSPAD. Gray area means a wall that can't be passed. Blue arrows mean passive resistance toward that direction. Here is an implemented scenario. A lever game object is simulated on the FSPAD. The second theme is control skill guidance. The FSPAD could help the user learning gaming skills by directly guiding them. And here is the third theme. Invisible interactions are done behind the screen, similar to a missing marble puzzle. You cannot see the maze inside the box, but somehow get that marble out of it by feeling it rolling through the tracks. The FSPAD transmits some non-visual information, hints on visually hidden items, skill trigger timings, or maybe obstacles inside the maze as shown on the right. Next is the avatar state feedback theme. When the avatar is hardly pushing a heavy boulder or box, the player will feel a resistance rendered on the thumbstick. Finally, the dynamic event feedback theme, which is also very straightforward. It represents huge collisions from car crash, attack from a monster, recoil from a gunfire, and many more. We conducted a user study with the FSPAD. We wanted to obtain feedback and collect insights from the real use of the FSPAD. Potential users of the FSPAD participated in our study. We demonstrated our sample game and conducted an interview after the demo. The demo game was a 3D adventure type game implemented with the Unity engine. The goal of the game is to control the swordman avatar until the endpoint while defeating monsters and solving various puzzles. As a result, participants gave various comments. Here I only present some representative ones. We analyzed the comments. We found positive responses from the users. Some comments helped us specifying the characteristics of the FSPAD. Also, we found actual needs for the FSPAD based on the participants' personal video gaming experiences. That makes the end of this presentation. If you are interested in building the FSPAD, please visit our website or contact the authors. Thank you for listening.